Hello viewers, in today's class we are going to discuss one important problem from limits, right? And here we have to find the value of this limit, which is the limit x tends to 0 and signum of x, right? So here we have the function involving the signum function, right? And we have to evaluate this limit, right? So here what we will do, we'll find out the right hand limit and the left hand limit of this function when x approaches to 0, right? And we'll see whether the right hand limit exists or not, and similarly the left hand limit exists or not, right? So let us find out both types of limits, that is the right hand limit and the left hand limit, right? So here we have the function that is f of x is equal to signum of x, right? And here we'll utilize the definition of signum function to find out the right hand limit and the left hand limit, right? So let us first define signum function, right? Now see, signum of x is defined like this, that is signum of x takes the value plus 1 whenever this x is greater than 0, right? And signum of x is 0 whenever x is 0, and signum of x is minus 1 whenever x is less than 0, right? So this is the definition of signum function. So now let us first find out the right hand limit, right? So for right hand limit, the notation is the limit x tends to 0, and here we have a positive sign, right? And we'll write this function, that is signum of x, right? Now see, here we have x is equal to 0, and when we find out the right hand limit, then it means we are approaching towards x is equal to 0 from the right of x is equal to 0, right? So here towards the right of x is equal to 0, we have a point that is 0 plus h, right? So this is the neighborhood of x is equal to 0. So here what we will do, we'll take x is equal to 0 plus h, where h is a positive quantity and h is here it is greater than 0, right? Or in other words, we can say that h is greater than 0 but it is less than 1, right? So h is infinitesimally very small. So now when x tends to 0, then obviously h tends to 0, right? So now the right hand limit, it takes the form that is the limit h tends to 0. So now we'll express this limit in terms of h, right? So we have limit h tends to 0, and here we have signum of 0 plus h, right? And now we can write this expression as the limit h tends to 0, and here we have signum of h, right? Because 0 plus h is h. Now see, h is a positive quantity, and we have just defined that signum function as signum of x is plus 1 whenever x is greater than 0 or x is positive, right? So signum of x is positive 1 whenever x is positive, right? So here we have h, and h is positive. So signum of h is equal to plus 1 because h is a positive quantity, right? So now we can replace signum of h by plus 1. So now we have a limit h tends to 0, and we have signum of plus 1, right? Now see, since here the function does not contain the variable h, so we can now drop this limit notation. So we have now simply signum of plus 1, right? And signum of plus 1, because 1 is a positive quantity. So when signum of x is plus 1, then x is positive. So here we have plus 1. So signum of plus 1 is equal to a positive 1, that is simply 1, right? So here we have 1. So the right hand limit of this function is 1. So now we can write the right hand limit as 1. Now let us find out the left hand limit. So the notation for left hand limit, it goes like this, that is x tends to 0 minus, and here we have a signum of x, right? Now see, when we find out the left hand limit, it means we are approaching towards x is equal to 0 from the left of x is equal to 0, right? So here we have a point that is 0 minus h in the neighborhood of x is equal to 0, right? So what we will do here, we'll take x is equal to 0 minus h, right? And h is obviously a positive quantity, that is h is greater than 0, and h lies between 0 and 1, and h is a very small quantity, right? So when x tends to 0, then h tends to 0, right? So now this limit, it takes the form in terms of h as limit h tends to 0, and here we have signum of 0 minus h, right? So now to evaluate this limit, we'll again make use of the definition of signum function, right? Now see, here we have limit h tends to 0, and we have signum of minus h, right? Now see, here we have minus h, right? So minus h is a quantity that is less than 0, that is h is positive, so minus h is a negative quantity that is less than 0. So when x is less than 0, then signum of x takes the value minus 1, right? So signum of minus h is equal to minus 1, right? So now this limit is equal to limit h tends to 0, and we have signum of minus 1, because signum of minus h is minus 1, right? And now see, signum of minus 1 is again equal to minus 1, because minus 1 is a negative quantity, and here we have x less than 0. So when x is a negative quantity, then signum of x is equal to minus 1. So signum of minus 1 is equal to minus 1. So now we can drop this limit notation. So signum of minus 1 is equal to minus 1, right? So we see that the left hand limit is equal to minus 1. So now viewers, here we have arrived at the conclusion that the right hand limit of this function, that is signum of x, when x approaches to 0 is 1, and the left hand limit is minus 1, right? And the right hand limit is not equal to the left hand limit, that is 1 is not equal to minus 1, right? So from the definition of limit of a function, we can now conclude that the limit of this function when x approaches to 0, it does not exist, right? So although the right hand limit is finite and it exists, and similarly the left hand limit is also finite and it exists, but both the limits, that is right hand limit and left hand limit, are not equal, because one is not equal to minus 1. So we can now say that the limit of this function when x approaches to 0, it does not exist, right? So viewers, this is how we can find out, or we can decide the limit of a function.